Howdy, Deadwood. Welcome to this here campfire story on CrowdSec. I'm Klaus. I used to be the sheriff around here, but now I'm head of the community of CrowdSec. I do a lot of talks like these. Since the time as a sheriff, I've lived in Copenhagen, where I'm part of the local InfoSec community for many years, and co-founded BTOS Copenhagen. Today, I'll talk to you about the problem of cybersecurity that is yet unsolved, because more and more companies get hacked. Companies spend fortunes trying to prevent this. And it seems like companies got used to throw a lot of money into a hole and hoping for the best without really questioning it. And the thing is, could we be doing this wrong? Because it's time for a new approach here. We tried outpowering the bad guys, that failed. We tried outsmarting them, that also failed. It's basically time to try something else. So how about outnumbering them? We haven't tried that yet. Because if you think of it, it makes sense. There are more of us than of the bad guys. So why not take advantage of that? Because nobody really wants to fight a beehive. If you see a beehive come at you, you run. But if it's a single bee, it's not so bad. So this is the basic idea. But what do you do with this in practice? What does this mean? Well, CrowdSec is basically trying to build the way of cybersecurity. If you don't know Waze, it's a GPS app. Users share data on traffic congestion, roadworks, and more, and they get an optimized route in return. Likewise, each CrowdSec agent collects data on attacks. It blocks those attacks and shares information about them with everyone else. This is a little bit about how CrowdSec works. First, you feed it with log because CrowdSec reads log. Then the CrowdSec agent detects threats. It mitigates those threats, and then it sends signals back to CrowdSec. CrowdSec assesses those signals, and then it shares the results as a block list with everyone else using CrowdSec. CrowdSec can deal with a number of different attacks. Not only brute force attacks, although most are. CrowdSec can detect any kind of deviation that can be described in a YAML file. So examples are web crawls, port scanning, credit card stuffing, layer 7 DDoS, just to name a few. Right now, CrowdSec is present in 175 countries. We collect around 15 to 16 million signals a day. Half of these is from a new collaboration with a company called GetShield that does WordPress security. So those are only related to them and to WordPress. The rest are those 8-9 million that we have. We have around 8-9 million IPs in our smoke database, which is like 3 days worth of data. Out of these comes a block list of around 21 or 22,000 IPs in a block list. CrowdSec is open source. We have chosen the MIT license for that. And what is special with the MIT license is that once you have made your code open source, it cannot be closed again. And that is by design, because CrowdSec is a young company. Some large company can buy us and want to close the source, and they can't do that. If that happens, the crowd would just fork and nobody would win. So what CrowdSec really offers is a fair deal. At least we think so. You get free to use software. In return, you share signals of your own attack, not about you, but about your own attack. What's important with CrowdSec, and the question that I usually get asked, is how do we deal with poisoning and false positives? And that is a very good question, because that is really important. But the way we deal with it is that we have implemented a trust rank. So meaning that every agent that submits signals to CrowdSec have a trust rank of 0. They start with that. And they will grow. That trust rank will grow as that agent is sending reliable signals to CrowdSec, and it can grow up to 99. And that is the result that will come out of 6 months of sending reliable data to CrowdSec. We use the trust rank when the consensus engine, as we call it, is assessing whether an IP is bad or not, because every time an IP is assessed, the agents ask whether they know this or not, and then they are able to vote based on the trust rank. This means that in order to affect the voting process, you need to have a high trust rank. The point of the trust rank will be added together and an IPU. And if an IP gets votes over a certain threshold, then it will be deemed malevolent. And the thing is that we really want to make it as hard as possible to affect the voting process. Of course, it's not impossible to do it and to poison the database, but we want to make it as hard as possible. So one thing is that it takes a lot of time to get a high enough trust rank. Another thing is that in order to affect the voting process, you need your agents are different ASNs, because one ASN only has one vote in this process. So that's just one more layer of complexity that makes it difficult and hard. In terms of false positive, we have our own little fleet of honeypots, and we use the signals of the honeypot to assess community signals or to verify community signals. On top of that, we have a wide list. There are certain IPs that you cannot block. For example, Google SEO Buzz or Cloudflare CDNs or something like that. On top of that, we have a predictive algorithm, which basically tries to block IPs before they do anything bad. The way it works is that it looks at how many IPs have come out of a certain net block, and at some point, depending on how big the net block is, we'll assume that everything coming from that net block is bad, so we'll block it whenever we see it and before they have done anything bad. And what happens in this process, the consensus engine or the consensus process, is that the IP is deemed malevolent if it is bad and thrown into the fire database and then distributed back to each client as block list. But enough talking. Now it's demo time, because actions speak way louder than words. So I'll show you how CrowdSec works by installing CrowdSec on one server and then attacking it with another one. To install CrowdSec, I've set up a VPS with Debian. We'll install on that using the official installation documentation on doc.crowdsec.net. Go to that and click install CrowdSec, and then you will see the instructions for Debian, which we're using here. Basically, the first thing you do is to add the CrowdSec repository. And after that, we will install the CrowdSec agent. During install, it will run the installation wizard, and what it does is to look at which OS we're running on, which services are running, and trying to install puzzles and scenarios for that. We are running on Linux. We have a MySQL running, Nginx, and SSHD, and detecting also means that it has set up protection for them as well. So the first thing we'll do is to try and attack this from our other VPS. First, I'll tail the CrowdSec log to see what's going on. So we'll attack the CrowdSec server using Nikto. And we can see already now that it has been that it's attacking, and it's not really blocking now because there is no bouncer installed. But we can see that the decision has been made to block, to do a CSCLI decision left. Yeah, so this is our IP, the IP of the Kali. So we need to verify that the bouncer works as it should. So in order for that, we need to access this VPS using the Kali server here. So in order to do that, we are doing an SSH tunnel that will forward from Kali to demo that we can connect to using our browser. So in order to verify that we can see what's going on CrowdSec server, we'll connect to Nginx using the attacker. And the way we'll do it is like that. We'll connect to port 880 on the CrowdSec server, and it will connect to the Nginx, and we have that now. So even though that we have been blocking it, nothing is blocked because there is no bouncer installed. The bouncer is the blocking part of CrowdSec. So in order to test that, I'll install the CrowdSec bouncer now. We go to while installing, we can go to the CrowdSec hub to see which bouncers are available. There's a AWS WAF bouncer, the block list mirror bouncer for firewall appliances, Cloudflare custom bouncer, Express Fastly firewall bouncer, ASA bouncer, and a few more. Most notably is the index bouncer is there, PSP bouncer, Windows bouncer, WordPress bouncer, and the traffic bouncer. Yeah, but in the meantime I've installed the Nginx bouncer. So if you refresh this page, it should be blocked. And this is what you see here is the Nginx bouncer. So now we're blocked. CrowdSec can also detect port scanning. I'll test that by first showing you the kernel log where a firewall is locked. And then we'll make sure that everything is being properly locked by the kernel. And it looks like this. Right. So if we go to the hub, we can see the IP tables collection here that does the actual log parsing. You see, it basically looks for IP tables drop on TCP and then block those. But first, we'll need to install the IP tables collection like this. And reload CrowdSec. And then tail the CrowdSec log. So then I'll do the port scanning again. And then, yeah. And then we can see here that we're getting banned here for our ban via the IP tables scenario. Multi-ports. So so even though I've tried to attacking this a little bit, but still there isn't really anything in the log, and that's a bit boring. CrowdSec has the ability to log code log, and this is an old log and a big one. So I'll try and load that into CrowdSec. It's a very useful function for when we are if you're doing forensics. Specify the log type in the Nginx, and we don't want it to start up API. We are running a several instances of CrowdSec, but we don't want it to run an API. Basically, just pass the file, and it will do that now. So you can see for each line, here is an attack that is being detected by CrowdSec. It just loads them into the CrowdSec database as if it was real life attacks. Right, and now it's in it. So to visualize it, we'll start up the dashboard. That is actually a built-in metabase Docker container that will be downloaded when I start it. And this will take a little while. Right, so let's try and access it. So CrowdSec has printed the credentials here. The password is randomly generated. So if you install yourself, make sure to write it down. So this is the main dashboard. You won't see, well, there is my attack from before, and that's another random attack that has been attacking us while it was up. But to see the imported data from 2019, we'll remove this, and then we'll see data from all time. So this is what we installed. This is a log we imported, and a number of different ASM has been attacking us. HTTP probing, bad user agents, open proxy, backdoor attempts, and a number of other attacks. These are the active decisions. So I hope this gave you an idea on how CrowdSec works and how easy it is to install, and some of the possibilities you have when you are visualizing it. I hope you enjoyed CrowdSec, and I really, really hope that you got inspired to use it yourself, because we would really love people to use CrowdSec, of course. If you want to get in touch with us, please connect with us on Twitter. You can join our Discord community, our friendly Discord community, where we also have workshops in CrowdSec. You can also send me a mail at cloud@crowdsec.net. And if you, like us, really like cool stickers, we really have a treat lined up for you. And since I'm virtually here, I'm not able to do this myself. So luckily, Debian Sticker Fairy, also known as Jason Blanchard, offered to help us in return. So if you go to the BHIS booth, he has a lot of stickers for you right there. And we would really love you to have one, or to have some, and to share with all your friends and colleagues. Thanks for your time.